Now we're going to look at both learning targets 2.3 and 2.4 from Unit 2 test. On this test, they were linked. If you only need to retake one learning target or the other learning target, however, you will only need to redo just one of them on your retake. So, they give me this scenario. People tended to be pretty good at writing the equations on the test. Where they had a problem was with the variables. So first I'm going to write the equation, because it's going to help me understand what variables I need. A screen printing company charges $60 setup fee. So if I already think in the terms of recursive routine, I need a 60 to start with. And then an additional fee of $4 for each shirt they print. So they're going to add $4 every time. Now instead of doing start with 60, then A&S plus 4, we say y equals 60 plus 4x. A lot of people want to put the x with the 60, but they're not charging $60 more every time they do something. They're charging a single fee of $60. They charge $4 every time they make another t-shirt, so I need the plus 4x. In this case, the y, the variables are not numbers. The variables are what do the y stand for and what do the x stand for in this problem. Well, if I'm taking, let's say I had 12 t-shirts, they would charge me $60 for a setup fee, and then they'd charge me $4 for every t-shirt. So I'd take 60 plus 4 times 12 to get my answer. If I only bought 5 t-shirts, they'd still charge me the $60 setup fee, but I'd only have to pay 4 times $5 for the actual t-shirts themselves. So it'd be 60 plus 4 times 5. If you notice what I'm doing every time, the x, 4 times the number, it's the number of t-shirts that I bought. So x is the number of t-shirts they print. Now, when they take 4 times the number of t-shirts and they add the $60, that tells me my total charge. It's not just the setup fee. The setup fee is $60, but the total charge is the $60 plus the $4 for every t-shirt. It's vital that you're careful with identifying your variables. You can have a wonderful equation, but if your variables aren't identified properly, your equation doesn't really say what you think it does. Now I'm going to skip ahead to this because it's going back to that same problem. We just did y equals 60 plus 4x, so I'm going to rewrite it here. And it said, what would the graph look like? So if I graphed this equation, how would the numbers from the equation, where would the 60 and where would the 4 show up in the graph? So 60 would be the y-intercept, and the line would rise because of this plus, so the line would rise, and I forgot the word line, would rise $4 for every t-shirt sold, or for every t-shirt ordered, for each, t-shirt ordered. So that's what it would look like. I would have 60 on the y-axis, so 60 would be on the y-intercept, and then the line that I drew would rise, actually it would be a set of points instead of just a solid line, would rise $4 for each t-shirt that I ordered. Now the second scenario says a truck is 185 miles east of Cedar Rapids, so I'm starting at 185, and it's driving west towards Cedar Rapids, and it wants the distance from Cedar Rapids. So the distance is going to decrease, in this case, by 62 miles for every hour that I drive. So y equals 185 minus 62x. Well, if I'd only been driving for 1 hour, I'd take 185 and subtract 62 once. If I'd been driving for an hour and a half, I'd have to take 185 to find out how far I am from Cedar Rapids. 185 minus 62 times 1.5. So the thing that I'm putting in for x every time is the number of hours that I've been driving. So the number of hours driving. And what I'm calculating each time, the y, is the distance from Cedar Rapids. So the distance from, and we know in Cedar Rapids, we do CR for Cedar Rapids. So it's perfectly acceptable on the test to abbreviate it that way. So going to what that graph would look like, my equation is y equals 185 minus 62x. Similar sort of wording. 185 would be the y-intercept. So I'm saying what the graph would look like. So it's not just the starting value. Where do I find the starting value on a graph? So it would be the y-intercept and the line it's not going up anymore, so it's not going to rise. The line would fall 62 miles for each hour. Now, by saying it this way, what it allows me to do is it not only gives me a visual that 185 has to be on the y-axis, but if it's falling 62 miles, it means also miles is my y-axis for each hour, so hours is going to be on my horizontal axis. So just this wording actually gives me a whole visual of what that graph's going to look like. Someone could take this and without looking at the equation at all, they could actually recreate this graph just from my description. So those are both Learning Targets 2.3 and 2.4 from the Unit 2 test.